Welcome to your lesson on the Earth and the season, the reason for the season. Right? Let's get a couple of important terms out the way. First of all, rotation. Rotation is when something spins on its own axis. So if you can picture a skater out on the ice just spinning in a circle, not going around the rink, but just spinning on the spot, that's considered rotation. And for large things like planets, we would say that is their day and their night. Day when they are facing towards the sun, night when they are not, when they're facing away from the sun. Okay? And of course, might be day in one half of the Earth and then nighttime in the other half of the Earth. For the Earth, we spin about 24 hours for one day and night cycle. So one complete spin takes us 24 hours. And we're spinning quite quickly in order to do that because we are quite large. So we're spinning at about 1,670 kilometers per hour, and we spin counterclockwise. Make sure you memorize this piece of information. Not so much the speed, but the counterclockwise motion. It's going to matter later on. Counterclockwise, in case you aren't familiar with that term, if you pictured a clock, and a clock would be, at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, and you're going this way around with the hands, if you go the opposite way to that a clock would move, it's considered counterclockwise. So in the opposite direction to a clock. That's why, as we're spinning, why we see that the sun seems to rise in the east and set in the west. Of course, the sun is actually mostly stationary, and we're the ones that are spinning. But the counterclockwise motion give us an east to west sunrise, sunset. There are other planets that move clockwise, but we just need you to memorize the Earth moving counterclockwise. We are also tilted, and we are tilted at 23.5 degrees. Please memorize this number as well. And of course, when we face the sun, it's daylight, and when we are facing away from the sun, it is nighttime. The other term you need to know is the term revolution. Now, revolution is considered a year. It takes us one complete year, which is 365 and a quarter days. That's why every 4 years we add an extra day, February 29th, and we call it a leap year because 4 quarters make a full extra day. So it's a little over 365. And that's the time it takes for us to take one complete orbit around the sun. While the spinning or the rotation of the Earth is spinning around its axis here, the revolution is the time it takes to orbit and travel all the way around. And of course, this takes 24 hours or 1 day, and this takes 365 days or 1 year to get back around to where we started. Okay. The other thing that's going to become more important when we talk about constellations is that our North Pole right here is always pointing at the exact same star away out in our, not even in our solar system, but far, far, far away. We always seem to be pointing at the same star, and it's called the North Star or Polaris because it's the pole star. But again, we'll talk about that in a different lesson. Let's get on to some of the terminology that's going to be very important for you to understand how we actually experience seasons. There will be a bunch of animations that we're going to watch that I'm going to direct you to after I finish the conversation. So that'll make things a little bit easier for you to understand because you'll actually see the motion of things that are going on. But let me just run you through the note, and then I'll give you some time to go off and watch those animations. So here we go. Let's start right here. The couple things that we need to define. The first one is the equator. Now, of course, you've heard of the equator before. That's the widest point of the Earth. This is where we're traveling at 1,670 kilometers an hour. Okay. So the equator is that fattest portion of the Earth. It splits the Earth right in half. But there are two other very important lines that you've probably never heard of, and that is the Tropic of Cancer, which is at 23.5 degrees north, and then the Tropic of Capricorn, which is 23.5 degrees south. Now, as we go through the seasons, when we are here in the north and we're sitting in spring, the sun is directly hitting the equator. But as we move this way, and we start to tilt towards the sun in the northern hemisphere, notice that the tilt is always the same direction, but we've moved, so we're now tilting toward the sun. The northern hemisphere, the sun actually begins to directly hit the Tropic of Cancer, which means that on either side of this area, you have way more sunlight available than you had when the sun was striking the equator. Then as we begin to move again around the other side of the sun, you can't see it very well, but it looks exactly like what's happening on this picture, where the sun goes back to hitting the equator exactly opposite this again. And then as we continue again and we move towards our winter, you can see we're now in the northern hemisphere, now facing or tilted, I should say, away from the sun. Notice that the sun is now directly hitting the Tropic of Capricorn. Okay, so this means that direct sunlight sits here, which means we get way less light, and that's why we're not getting as many hours of daylight right now in winter, although our days are beginning to get longer. We'll talk about that in a second as well. But notice that when the sun is hitting the equator, either in this diagram at the top or this one at the bottom, you actually are going to have equal amount of sunlight hitting the north and hitting the south of the earth, of those different hemispheres. So we would consider this spring because we are on our way into summer, where we'll get longer days and we'll get more sunlight in the northern hemisphere. But at the exact same time that we are gaining light, notice that the southern hemisphere is now pointed down or not directly in the line of fire of the sun, so it's not getting as much. That's why we can consider that the north will be in summer. We're getting way more daylight, more direct sunlight, I should say, than the south, which is getting more indirect light. So it's cooler down here and it's hotter up here. Then we come back around where it strikes the equator again, and then we get equal temperature, equal amount of light. So in the autumn for the north, because we're coming out of summer and heading towards winter, but it'll start to become spring in the southern hemisphere. Because as they move towards this direction, the sun is now hitting them more directly in that southern area. So winter for us, summer for them. So that means that our seasons are actually caused by a combination of our revolution, so we're going around the sun, and how we're tilted, either in this case towards the sun, or tilted, in this case, northern hemisphere away from the sun, and the south tilted towards the sun. Okay, so again, the hemisphere that's fully pointed towards the sun gets lots of direct sunlight and heat. That hemisphere will be in summer. It'll have long days, more than 12 hours of daylight. A hemisphere that gets pointed away from the sun has very little direct sunlight and therefore heat, and so it will be experiencing winter, short days, less than 12 hours of daylight. When both hemispheres receive equal sunlight, that's because the sun is hitting the equator, so north and south are getting the same direct light. Then you have spring and autumn, spring in the north, autumn in the south, or spring in the south, autumn in the north. Obviously, they're opposite to each other. And that's when you're getting roughly half the day would be in daylight. Now, the more direct the sunlight is, so if you're hitting straight down, then you'll see that it's the same width between these rays, but it only hits a very small area. Whereas if you have the same width between the rays, but you have it at an angle, you spread out that light. So this is lots of heat in a small area, so that'll be much hotter. And then same amount of light, but spread out over an area, means the temperature will be lower in that particular area. So when the sun is directly smacking into the equator, it's warmish between both sides, same. When the sun is hitting the Tropic of Cancer, then it'll be hot in the northern hemisphere. When the sun directly hits the Tropic of Capricorn, it'll be hot in the southern hemisphere. So direct sunlight, hot, indirect, cool. Lots of terminology that goes along with these different parts and times of the year. In the northern hemisphere, I'd like you to memorize these 4 terms: summer solstice, winter solstice, vernal equinox, and autumnal equinox. Add this word into your handout. And I need you to memorize these dates: June 21st, December 21st, March 21st, and September 22nd. You can also say 21st for this one as well. Sometimes it's a little bit different because we have leap years, right? Now, what is the summer solstice? Well, that is the very day that the sun strikes the Tropic of Cancer. That is the summer solstice. It is the longest day of the year for the northern hemisphere, okay? Longest for the northern hemisphere, and it's the start of our summer, the summer solstice, okay? On the exact opposite, when the sun is striking the Tropic of Capricorn, it might be summer in the southern hemisphere, but in the northern hemisphere, that's our first day of winter. So the winter solstice, It's the start of our winter, and it is our shortest day of the year, December 21st. If you have the sun striking the equator, either in this situation here or when the Earth is on this side, then you've got your autumn or fall, and we're going to call it the autumnal equinox, because I'm coming from summer on my way to winter, right? So this is my autumnal equinox, and then because I'm in winter here and then I'm coming back around, I am now in the vernal equinox, sometimes called the spring equinox as well, but please use the term vernal, okay? Vernal equinox, and both of those will be the start of their season, so vernal being spring and autumnal being autumn, and both of those days will have exactly 12 hours of daylight, both times. So here on our way to summer, our days are growing longer. Then they have the longest day, they get shorter until they're 12 hours, and then they get shorter and shorter and shorter until you hit the winter solstice, and then the days grow longer again as we're heading back on our way towards summer. Okay? Please memorize the fact again that the Earth is rotating counterclockwise, and also memorize that the Earth's revolution is also counterclockwise as we go around the sun. And that, my friends, is the end of this part of the note. Please make sure you copy all the details down. And then what I'd like you to do is go over to our website, go to Content, go to Space Unit, and then go down to the YouTube links. You should already have seen these YouTube links from the last lesson, okay? Now it's time for you to scroll down and go to the planets and Earth seasons videos. And I'd like you to watch number 2, number 3, and number 4. And you can also watch these ones as well when it looks at the midnight sun. Very interesting little video. So please make sure you run through and watch all 7 of those videos so that you can have a better understanding of how the planet Earth is actually experiencing its seasons. All right, and that is the end of this particular lesson. Go ahead and watch those videos and do the text homework that's assigned in your unit outline.